All right, well, here we go with question 2017, number 4. And this is a pretty big one. We've seen a couple differential equations that look similar to this. So if you had a rough time with this one, or maybe you did really well with it, but if you did, let's just slow down and really talk this out. So at t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature is 91 degrees. So let's kind of box that in. Obviously, by now, you should be highlighting that, and we should be labeling that as the initial condition. And here's the thing. So when t equals 0, the temperature of the potato is 91 degrees. And we're going to give that a label in just a moment. And the internal temperature of the potato is greater than 27 degrees for all times t is greater than 0. The internal temperature of the potato in t minutes can be modeled by this differential equation. Okay, where h of t is measured in degrees Celsius and h of 0 equals 91. So this is actually h here. Okay, so at t equals 0, the h, they're calling that your temperature, the h, which is the internal temperature of the potato, measures 91. So they gave you this differential equation, dh dt equals negative 1/4 times h minus 27. Now, I want you to think of it like this. What do we typically call a differential equation? We usually call it dy dx, correct? So think of it as this is like the y and this is like the x, but they want you to use h and t. And I think just them changing the letters on it made it a little more confusing. So always go back to what you call it, dy dx, and so the top is going to be like your y, the bottom is going to be like your x. So part A says write the equation for the tangent line to the graph of h at t equals 0. Then use this equation to approximate the internal temperature of the potato at t equals 3. So let's go back to the one thing they told us. H of 0 equals 91. And, well, they gave us two things. dh dt equals negative 1/4 times h minus 27. All right, so let me go back to the directions here. Write the equation for a tangent line. So in my head, I'm saying, okay, y minus y1 equals m times x minus x1. Now remember, there are no x's and y's. There's h and there's t. H we said is like the y because we called it dy dx. So I'm going to replace this with h minus h1 equals m. And there's no x's because the t is like the x. T minus t sub 1. And once you do that, I think it makes it a little more straightforward. I'm going to plug in my initial condition, h of 0 equals 91. So h minus 91 equals some slope times t minus 0. And now I need to figure out the slope. And how convenient that that's the definition of a differential equation. This is the slope. So dh dt is equal to negative 1/4 times the h, the internal temperature, which is 91 minus 27. So I'll have to do a little scratch work. 91 minus 27. Carry the 1 should get me a 64 times negative 1/4. So I've got a nice dh dt is equal to negative 16. All right, so I've got the equation of the tangent line. Now it says use that tangent line to approximate t equals 3. So now is the easy part. I'm just going to plug in, just a minute, buddy, 3 in. So I've got h minus 91 is equal to negative 48. Add that 91 over. And I've got h equals 43 degrees Celsius. And again, that's when the t value was 3. All right, part B, find d squared h dt squared h. So they're asking us to find the second derivative and then determine whether your answer is an under or over estimate. So let's forget about that part, but let's first find that second derivative. So obviously I need my first derivative. dh dt was negative 1/4 times h minus 27. And I need to derive this. Hopefully very simple. You could do one step first. If you wanted to take this negative 1/4 and distribute it, go for it. Sometimes that makes it easier. So dh dt is equal to negative 1/4 h minus, I guess that's plus 27/4. Okay, so basically what are we doing? We're taking both sides and we're going to take its derivative. All right, so I want to derive all of this. Okay, so when I derive dh dt, that's the first derivative, I now get d squared h dt squared, taking the derivative of this side, and now I'm going to derive this side. Now notice though, guys, it's with respect to time, so it's a related rates question, essentially, if everybody's going to get a d something dt. So this becomes negative 1/4, and the derivative of h, because it's with respect to time, becomes d h dt. And 27/4 is a constant, so its derivative is 0. Okay, so now I have negative 1/4 times dh dt. Now we actually know dh dt because it's sitting right here. So I'm going to clean this up further and say I have negative 1/4 times negative 1/4 h minus 27. And as I clean that up, I get a positive 1/16 times h minus 27. Now, I need to know whether this is positive or negative to know whether I have an under or over estimate. And at t equals 3, if you look back to part A, when t equals 3, we said the approximation of h was 43. So if I plug in 43, I'm just going to arrow up because I'm losing some space here. I have 1/16 times 43 minus 27, and I'm just going to say that that number is greater than 0. I don't really care what it is, I just need to know whether it's positive or negative. So now to answer the question, if my second derivative is positive, so that describes concavity, I am concave up, and I'm going to draw a picture to verify that. Then I know my tangent line has to sit under. No matter where I draw it, that tangent line has to sit under. So this would be an under approximation, and my justification would be that second derivative is positive. All right, so now the big question. They give us an alternate model of the temperature of the potatoes given by this differential equation. So this is just another model, it says. And here's your initial condition. Find G. So you need to get G by itself. And basically all they're asking you to do is solve this particular solution to get G by itself. And again, most people are pretty good at that. So G d dt equals negative G minus 27 to the 2/3. So I'm just going to separate and integrate. And put this over 1 and kind of cross multiply. dg over, I'm actually going to leave the negative there and just go g divided by 27 to the 2/3 equals negative dt. You could bring the negative over if you want. I just chose not to. Integrate both sides. So this is going to get me a negative t plus c, because that's like having a negative 1, obviously. Here I'm going to do a u sub. U is equal to g minus 27. du is equal to dg. So here I'm going to integrate u to the negative 2/3 du. I'm going to carry my work over to this side here. So this side I already integrated, so I've got negative t plus c. When I integrate this, I'm going to add 3/3, so I get u to the 1/3 divided by 1/3, or times 3. And I'll plug that original back in. So I have 3 times g minus 27 to the 1/3 equals negative t plus 3. Plug that condition in of 0, 91. So just get a c here. So I get 3 times 91 minus 27 to the 1/3. Again, a little scratch work off to this side. 91 minus 27 is 64, so I get 3 times 64 to the 1/3. That's the cubed root of 64 is 4. 4 times 3 is 12. So I think I've got 12 equals C. So now I'm going to take that condition and plug it back in. Oops. So I've got 3 times g minus 27 to the 1/3 equals negative t plus 12. To solve that equation, I'm just going to divide both sides by 3. So now I have g minus 27 to the 1/3 equals negative t plus 12 over 3. No need to clean that up. 1/3 is like having a cubed root, so to undo that, I just raise all this to the 3rd, and then I'll raise this side to the 3rd. So now I'm running out of room here. G minus 27 is equal to negative t plus 12 over 3 to the 3rd. And then lastly, I just need to move that 27 over. So g equals negative t plus 12 over 3 to the 3rd plus 27. And then lastly, what you always want to do after you solve a differential equation is make sure the condition holds. And I think that was g of 0 equals 91. So if I plug in 0, I should get 0 plus 12 is 12 divided by 3 is 4. 4 cubed is 64 plus 27, which does equal 91. So I know that checks out, and here's my function. I can throw a t in there for g of t. And lastly, I just want to make the point that if you got any of these questions completely wrong, that's okay if you do something about it. You probably need to go back and try this question again. Grab a new sheet of scrap paper and try it again. Doesn't have to be the second. Maybe it's in an hour, maybe it's in 2 hours, maybe it's tomorrow. But you probably need to redo these over and over until you're very confident with them.